The universe is a place of endless, beautiful mysteries. We are living through a golden age of discovery, where new telescopes and sharp minds are revealing cosmic secrets at a staggering pace. Today, we are exploring 25 of the most incredible, newly discovered space phenomena, each one challenging the very foundations of what we thought we knew. By the end of this journey, you will have a front row seat to the bleeding edge of astronomy, where the rules of physics are being rewritten. We will encounter a galaxy made almost entirely of invisible matter and a star with a chemical composition that should be impossible. What single cosmic mystery has always captivated your imagination? The most our journey begins with a cosmic phantom, a structure of such immense scale it was hiding in plain sight for eons. Astronomers have discovered a radio galaxy they call Alcyoneus, a name borrowed from the primordial giant of Greek myth, and for good reason. This entity is the largest single structure of galactic origin ever identified. To grasp its scale, imagine a single galaxy, but with colossal jets of plasma erupting from its core, stretching so far into space that they would take millions of years for light to travel from one end to the other. It dwarfs our entire Milky Way to the point of insignificance. This discovery was made possible by the LAFAR telescope network, an instrument so sensitive it can detect the faintest radio whispers from the deepest voids. Finding Alcyoneus was not just about breaking a size record. Its very existence acts as a cosmic probe, telling us something profound about the space between galaxies. That space, the intergalactic medium, is not a perfect vacuum. It is threaded with incredibly weak magnetic fields, and the immense jets of Alcyoneus are like a spotlight, illuminating their presence. The fact that these jets can remain coherent over such staggering distances means the magnetic fields in the cosmic web are far more widespread and structured than we ever believed. This ghost is not just a curiosity. It is a fundamental clue, rewriting our understanding of the invisible forces that shape the cosmos on the very largest scales. Moving from a phantom of immense scale, we now find a cosmic fugitive on the run. The Hubble Space Telescope has captured something that defies all expectation: a supermassive black hole, an object of almost incomprehensible density, not at the center of a galaxy where it belongs, but fleeing across the void. It is a runaway, and in its wake, it is not leaving destruction, but a trail of newborn stars. This celestial paradox is like a gardener scattering seeds as they run, creating a thin, brilliant bridge of young suns stretching over 200,000 light-years. The leading theory for this incredible event involves a gravitational ballet of three supermassive black holes. When two galaxies merge, their central black holes often spiral toward each other. But if a third arrives, the resulting chaos can act like a cosmic slingshot, violently ejecting one of the trio at incredible speed. This discovery fundamentally challenges our picture of galaxy evolution. We assumed these monsters were anchored to their galactic cores, governing the growth of stars from a central throne. Now we must consider that they can be violently uprooted, sent careening through intergalactic space, and in their turbulent passage, they can ignite the fires of creation. The universe, it seems, has more than one way to build a star. This wandering black hole is not the only cosmic traveler to have recently crossed our path. Far closer to home, a tiny, enigmatic visitor from another star system slammed into our atmosphere. On January 8, 2014, a fireball lit up the skies near Papua New Guinea. Data from top-secret United States government sensors designed to monitor for nuclear detonations recorded the event. For years, it was just another entry in the catalog. But then, astronomers took a closer look at the numbers. The object, designated CNEOS 2014-0108, was moving at an incredible speed, over 130,000 miles per hour. Its trajectory was the real shocker. It was not orbiting the Sun like everything else in our solar system. It was on a hyperbolic path, a clear sign it was an interstellar traveler, the first we have ever observed impacting our planet. This was not just a rock from our backyard. It was a piece of another star system delivered to our doorstep. The scientific implications were staggering, prompting a high-stakes expedition to the Pacific Ocean floor. Using meticulous analysis of the fireball's path, a team led by scientists from Harvard pinpointed a potential debris field. They sailed to the location, deployed a magnetic sled, and dragged the seabed, hoping to find fragments of this otherworldly visitor. They recovered tiny, molten metallic spherules, and initial analysis suggested a composition unlike any known solar system asteroid. The materials were extraordinarily tough, with a strength that defied natural explanation for a simple space rock. This is where the mystery truly deepens. The extraordinary properties of these fragments have ignited a fierce and ongoing debate. Could this object, known as IM-1, have been artificial in origin? Was it not a random asteroid, but a piece of technology from a distant civilization? A probe that ended its long journey in a blaze of glory over our ocean. The data is controversial, and many scientists urge caution, pointing to potential measurement errors or natural explanations we have not yet considered. Yet the possibility remains, hanging in the air like the echo of that long-vanished fireball. We may have already picked up a piece of someone else's starship from the ocean floor. A silent messenger from the vast and unknown dark. Just when we thought we understood the basic ingredients of a galaxy, the universe presents us with a ghost. Lying in the tranquil darkness, a mere 300 million light-years away, is an object designated J0613+52. It was found entirely by accident by the colossal Green Bank telescope, a radio dish nestled in the quiet mountains of West Virginia. Astronomers were simply surveying other, ordinary galaxies when this one drifted into view. At first, it appeared as little more than a whisper of hydrogen gas, a faint, rotating cloud. But as they focused their instruments, they realized they were looking at something that should not exist. This was a galaxy in every structural sense, spinning and held together by gravity, yet it was almost completely devoid of stars. It is a dark galaxy, a cosmic phantom ship adrift on an invisible sea of dark matter. Its visible mass, the sparse gas and the tiny number of stars, is utterly insufficient to provide the gravity needed to keep it from flying apart. The only thing holding it together is the immense, unseen gravitational grip of dark matter. This discovery is a profound challenge. Our current models of galaxy formation suggest that pockets of dark matter should act as seeds, pulling in vast amounts of gas that then cools, condenses, and ignites into stars. J0613+52 has the dark matter seed and the gas, but for some mysterious reason, the star formation process never truly began. It is a cosmic stillbirth, a fossil from the early universe that has remained frozen in time. Why did this galaxy fail to light up? Was the gas too turbulent, too diffuse, or was it never disturbed by a nearby galactic encounter, the kind of collision that often triggers stellar birth? This dark galaxy forces us to ask if the cosmos is littered with such invisible structures, a hidden population of failed galaxies that have been there all along, just beyond our sight. From the silent darkness of a failed galaxy, we turn to a spectacular cosmic death. The Boomerang Nebula has long been a textbook example of a star's final act, a beautiful, symmetric hourglass of gas and dust. But the James Webb Space Telescope has just shattered that perfect picture. Its unprecedented infrared vision has peeled back the outer layers of this familiar object, revealing a truth far more chaotic and magnificent. The nebula is not a simple boomerang at all. It is a complex, multi-lobed structure, with vast, petal-like streams of molecular gas erupting in all directions from the dying central star. This is the death cry of a sun-like star, captured in impossible detail. For decades, astronomers believed they understood the physics behind these bipolar planetary nebulae. The elegant shape was thought to be sculpted by a tight, high-speed stellar wind from the star's core, pinched by a dense ring of dust around its equator. Webb's new image proves that model is far too simple. The reality is a messy, violent, and multi-stage process. The star is not dying in a single, graceful exhale, but in a series of fitful, powerful bursts, each one ejecting material in a different direction and at a different time. This forces a complete rethinking of the final millennia of a star's life. The mechanisms that shape these glorious cosmic graves are more complex and turbulent than anyone predicted. It is a beautiful reminder that even in death, a star can surprise us, revealing new layers of physics in its final, brilliant display. Our own solar system holds landscapes that are both alien and strangely familiar. The surface of Mars, a world we have mapped in exquisite detail, still conceals moving patterns on a monumental scale. Orbiting spacecraft have identified enormous waves of sand and dust, features scientists call megaripples. These are not the small, everyday dunes we might see in a desert on Earth. These structures can stretch for hundreds of feet from crest to crest and stand stories high, forming a vast, frozen ocean of granular material. For a long time, planetary geologists believed these megaripples were relics of a more active, wind-swept past, ancient features frozen in time. But the combined eyes of orbiters and the tireless rovers on the ground have delivered a stunning revelation. These colossal features are on the move. They are migrating, shifting slowly but surely across the rust-colored plains, driven by the thin Martian winds. This discovery transforms our understanding of the red planet from a static, dusty museum into a world with a subtly active geology. The movement of these megaripples is a direct record of the current wind patterns, a logbook written in sand. By studying their direction and speed, we can decode the atmospheric forces shaping Mars today. Furthermore, the composition of these megaripples is a puzzle in itself. They appear to be made of coarser, heavier sand grains than the fine dust that covers so much of the planet. How does the thin Martian air, with less than 1% of the pressure of Earth's atmosphere, have the strength to push these much larger particles into such organized, massive forms? The answer may lie in rare but powerful wind events, global dust storms that can whip the entire planet into a frenzy, providing the brief bursts of energy needed to rearrange these gigantic features. Each migrating megaripple is therefore a message, telling us not only about the wind of today, but also about the history of sediment and the violent storms that have sculpted this world for billions of years. The sands of Mars are not the only place where the universe leaves its cryptic messages. Deep within the stellar graveyard, astronomers have found a star that defies all known chemical recipes. It is known as J0931 plus 0038, and it is a retired star, a red giant that has burned through its fuel and now quietly cools. But its serene appearance is a complete lie. When scientists with the Sloan Digital Sky Survey analyzed its light, they found a chemical fingerprint that should be impossible. This star possesses staggering amounts of certain rare heavy elements, like nickel and zinc, while being almost completely devoid of others. It is as if a cosmic chef followed a recipe that broke every rule in the book. Stars are the forges of the universe, creating elements through nuclear fusion in their cores and scattering them in violent supernova explosions. The chemical makeup of a retired star like this one is a fossil record, a direct imprint of the single supernova that seeded the cloud of gas from which it was born. But the pattern etched into J0931 is unlike any other supernova signature we have ever seen. The amounts and ratios of the elements present are so extreme, so bizarre, that they point to a type of stellar explosion that has never been observed and was only theoretical. The leading theory suggests this star is the offspring of a failed supernova, a truly colossal star that almost managed to collapse directly into a black hole. In this model, the star's core would have begun to implode, but a powerful shockwave, fueled by the intense energy of neutrinos, might have blasted outward just for a moment. This brief, incredibly energetic burst would have created a very specific and unusual suite of heavy elements in a rapid nuclear frenzy, before the star's outer layers fell back, smothering the light and forming a black hole with barely a whimper. This faint, dark explosion would have left no brilliant flash in the sky for our telescopes to see, only this one chemical fossil as its sole witness. This single, quiet star is therefore a time capsule, holding the evidence for one of the universe's most violent and secretive events, a ghostly supernova that we can only now begin to decipher. These stellar predators spin with a ferocity that defies comprehension. Deep within the ancient, dense star cities known as globular clusters, astronomers have discovered a terrifying new class of pulsar. They call them spider pulsars, and they live up to their namesake's gruesome reputation. A pulsar is the ultra-dense, rapidly spinning corpse of a massive star, a magnetized ball of neutrons no larger than a city, yet weighing more than our sun. These particular pulsars are not solitary. They exist in binary systems, locked in a tight, deadly gravitational embrace with a companion star. But this is not a partnership of equals. The pulsar bombards its nearby neighbor with relentless blasts of radiation and a gale of high-energy particles, a stellar wind of unimaginable violence. This constant assault is systematically stripping the companion star of its outer layers, evaporating it into space. It is a slow, cosmic dismemberment. Scientists have even categorized these celestial arachnids by their methods. There are the Black Widow pulsars, which have already consumed most of their stellar companions, leaving behind a tiny, scorched remnant, a planet-sized cinder. Then there are the even more extreme redback pulsars, named for the Australian spider known for its gruesome mating rituals. In these systems, the companion star is still substantial, a bloated, sun-like star being cannibalized alive. The pulsar's intense winds and radiation heat one side of the companion to temperatures of thousands of degrees, creating a horrifyingly lopsided star that glows brilliantly on just one face. This slow destruction provides astronomers with a unique and brutal laboratory. By watching a spider pulsar feed, we can measure the incredible density and magnetic fields of the pulsar itself. We can study the physics of plasma, the fourth state of matter, under conditions impossible to recreate on Earth. The eventual fate of these systems is written in their violence. The pulsar will continue to siphon material and energy from its partner, spinning ever faster, until it either completely destroys the other star or flings it away into the dark. These celestial dramas force us to confront the most extreme relationships in the universe, where life for one object means a slow, agonizing death for another. While stellar predators spin in the void, a different kind of mystery churns in the atmosphere of our solar system's giant. Jupiter, a world of swirling, tempestuous clouds, holds a secret that is not a storm of heat and fury, but one of profound cold. Data from the Juno spacecraft has uncovered a massive, persistent dark spot in the planet's upper atmosphere, a feature scientists have named the Great Cold Spot. This is not the famous Great Red Spot, a centuries-old hurricane larger than Earth. This spot is something entirely different, a vast region of extreme cold, hundreds of degrees Fahrenheit below its surroundings, and sprawling across an area that could easily swallow our entire planet. It is a ghost in the Jovian sky, an atmospheric hole that is invisible to the human eye, detectable only by its chilling fingerprint in infrared light. Its very existence defies our basic understanding of weather on gas giants. How can such a colossal, stable cold region persist within the planet's chaotic, energetic cloud bands? The answer appears to lie not in the churning clouds below, but in the dazzling lights above. The Great Cold Spot seems to be intrinsically linked to Jupiter's powerful and permanent auroras. These are not like our fleeting northern lights on Earth. Jupiter's auroras are a constant, roaring inferno of energy, generated by the planet's immense magnetic field interacting with charged particles from its volcanic moon, Io. This torrent of energy pouring into the poles does more than create a light show. It also appears to be driving a massive, planet-scale weather system. The theory suggests that the intense heat from the auroras sets up a kind of atmospheric thermostat, creating a vast circulation pattern that, in turn, funnels and traps this immense pocket of frigid air. This makes the Great Cold Spot not a simple weather feature, but a permanent secondary effect of the planet's dazzling polar lights, a previously unknown type of atmospheric phenomenon. Its discovery forces us to reconsider the complex energy balance of gas giants, revealing that their weather is not just driven by the sun's heat from above or internal warmth from below, but also by the powerful, invisible forces of their own magnetic hearts. Our galaxy is haunted by invisible ghosts. For decades, astronomers have theorized that the Milky Way should be filled with millions of solitary black holes, the dark remnants of massive stars that died in supernova explosions. These corpses were predicted to be drifting silently through the void, utterly dark and impossible to see. Now, for the first time, we have definitively caught one. This is not a supermassive black hole at a galaxy's heart, nor one in a binary system feeding on a companion star. This is a stellar mass black hole, utterly alone, and its detection required one of the most subtle techniques in all of astronomy: gravitational microlensing. The principle is based on Einstein's theory of relativity, which tells us that a massive object warps the fabric of space-time around it, acting like a lens that bends and magnifies light. When a lone black hole passes almost perfectly in front of a distant background star, its immense gravity briefly focuses the star's light, causing it to brighten for a period of weeks or months in a very specific, telltale pattern. For years, telescopes have watched for these events, but the challenge has always been confirmation. A passing planet or a dim, faint star could create a similar brightening. The key to identifying this particular event as a black hole was a combination of the extreme magnification of the background star and a complete absence of any light from the lensing object itself. After meticulous analysis, astronomers concluded they were looking at a gravitational phantom with a mass roughly 7 times that of our Sun, all compressed into an invisible point. This discovery opens a window into a hidden population. Every solitary black hole we find helps us take a census of stellar death. It tells us how many massive stars end their lives not with a partner, but alone, and how their supernova explosions can sometimes kick them away from their birthplaces, sending them on eternal journeys through the galactic dark. These rogue black holes are the silent, unseen nomads of the cosmos, and we have finally proven they are real. This relentless evaporation is not just a theory. We are seeing it happen in real time around a world known as WSP-69b. This exoplanet is a hot Jupiter, a gas giant orbiting so close to its star that a full year passes in less than 4 Earth days. The stellar inferno is so intense that it is literally boiling the planet's atmosphere away, blasting it into space. But the newest observations reveal this is no gentle haze. The planet is trailed by a colossal, comet-like tail of escaping gas, a shimmering stream that stretches for an astonishing 350,000 miles. That is longer than the distance from the Earth to the Moon. We are witnessing a planetary system actively dismantling one of its own worlds. For astronomers, this is a priceless opportunity. WSP-69b acts as a natural laboratory, allowing us to study a process called hydrodynamic escape. The star's intense radiation is heating the planet's upper atmosphere to thousands of degrees, giving the gas particles enough energy to overcome the world's gravity and flow away like a river. By measuring the composition and speed of this escaping material, we can learn fundamental rules about how planets lose their air. This has profound implications for our understanding of all worlds, including those that might harbor life. Billions of years ago, when our sun was younger and more violent, Mars may have lost its thick, protective atmosphere through a similar, though less extreme, process. Watching WSP-69b slowly erode gives us a front-row seat to the forces that can make or break a planet's habitability. A stark reminder that a world's location is the ultimate determinant of its fate. Even the darkest corners of space can hide profound secrets. Near the chaotic heart of our own Milky Way galaxy, the James Webb Space Telescope has focused its infrared gaze on a cosmic enigma nicknamed the Brick. This is not a glittering nebula or a bustling stellar nursery, but a colossal, dark cloud of gas and dust so dense it appears as a silhouette against the galaxy's bright core. For years, astronomers assumed this massive, cold lump of material was a star factory in the making, a reservoir of matter so packed that its own gravity should be causing it to collapse inward, igniting countless new suns. Yet Webb's penetrating vision has delivered a stunning surprise. The brick is quiet. It is eerily quiescent, showing almost none of the violent, early star formation that everyone expected to find. This deep silence is a major puzzle. Why is this cosmic cradle refusing to give birth? The answer seems to lie in the cloud's internal turmoil. The gas within the brick is not calm and cool, ready to condense. Instead, it is turbulent and surprisingly warm, heated by external pressures and likely threaded with strong magnetic fields. These internal forces may be providing enough support to counteract the pull of gravity, putting the entire process of stellar birth on hold. This single, dark cloud is therefore forcing a fundamental rethink of what triggers star formation. It suggests that simply having enough mass is not enough. The internal state of the gas, its temperature, motion, and magnetic energy, are the true gatekeepers of creation. The brick stands as a monumental, dark question mark at our galaxy's center, challenging us to understand why some clouds of dust light up the universe, while others remain in stubborn, silent darkness. Deep within the cosmos, a signal beats with the steady rhythm of a heart. Astronomers have captured a fast radio burst, one of the most energetic and mysterious events in the universe, that repeats with a clear 16-day period. For a few days, it erupts with multiple, unpredictable flashes, and then it falls silent for over a week before starting its cycle all over again. This is the first time we have ever seen such a precise, clockwork pattern in an FRB. These bursts themselves are astonishing, releasing more energy in a millisecond than our sun emits in 3 days, all from a source billions of light years away. For years, their origin was a complete enigma, with theories ranging from crashing neutron stars to alien civilizations. This new rhythmic FRB is a game-changer. That steady pulse is a massive clue, pointing toward a physical system that is moving in a predictable orbit. One compelling idea involves a highly magnetized neutron star, a pulsar that is wobbling. Imagine a spinning top as it slows down, its axis tracing a slow circle. This wobble, called precession, could cause the beam of radiation from the pulsar to sweep across our line of sight only at a specific point in its cycle, creating the periodic pattern we observe. Another possibility is that the neutron star is locked in a tight, eccentric dance with a massive companion star. As it travels along its elongated orbit, it might only vent its colossal bursts of energy when it comes closest to its partner, perhaps plowing through a disk of material surrounding the other star. This regular cadence provides the first real structural blueprint for these cosmic powerhouses. It rules out one-time cataclysmic events and suggests instead a repeating engine, a cosmic machine that operates on a schedule we are only just beginning to decode. This search for life leads us to a distant, water-shrouded world. K2-18b is a super-Earth orbiting within the habitable zone of a cool red dwarf star, over 100 light-years away. For a world to be habitable, it needs more than just the right temperature. It needs an atmosphere. The James Webb Space Telescope turned its gaze to this exoplanet and performed a feat that was once the realm of science fiction. As K2-18b passed in front of its star, Webb analyzed the starlight filtering through the planet's atmosphere. Different molecules in the air absorb specific colors of light, leaving behind a unique chemical fingerprint. The results were staggering. The atmosphere of K2-18b is rich in hydrogen and helium, but crucially, it also contains carbon dioxide and methane. This combination is a powerful clue. On Earth, carbon dioxide and methane are often part of the same biological cycle. Finding them together in a Hycean world's atmosphere, a theoretical class of planet with a vast liquid water ocean beneath a hydrogen-rich atmosphere, is incredibly tantalizing. But the most electrifying finding was a potential, though unconfirmed, signal of dimethyl sulfide. On our planet, dimethyl sulfide is a molecule only produced by living organisms, specifically by phytoplankton in marine environments. It is a biological calling card. If this detection holds up to further scrutiny, it would mark the first time we have ever found a potential biosignature, a sign of life, in the atmosphere of another world. The implications are so profound they are difficult to overstate. We are not talking about simple, single-celled organisms in a nearby pond. This would be evidence of a complex biological process occurring in a global ocean on a world entirely different from our own. The discovery forces us to confront an extraordinary possibility. Life may not be a rare, precious fluke confined to our pale blue dot, but a common, even inevitable, feature of a universe rich with water and the building blocks of biology. K2-18b now stands as a beacon, a world that has shifted the search for life beyond our solar system from a question of if, to a question of where, and how soon we can look again. Gamma-ray bursts are the universe's most powerful explosions, but we have only ever seen them through a keyhole. For decades, our instruments could only capture the lower energy light they emitted, giving us a limited, incomplete picture of their true violence. That all changed when the MAGIC telescopes, a pair of giant, ground-based eyes designed to see the most energetic light in the cosmos, caught the afterglow of a gamma-ray burst and witnessed something unprecedented. They detected photons with energies in the tera-electron-volt range, abbreviated as TeV. To grasp that scale, a single one of these photons carries 1 trillion times more energy than a particle of visible light. This was the first time we have ever seen such tremendously high-energy light from one of these events. It is like hearing a symphony for your entire life, and then suddenly discovering it has a bass line so deep and powerful, it shakes the very foundations of the concert hall. This discovery immediately shattered our existing models for what happens in the aftermath of a gamma-ray burst. The prevailing theory suggested that the initial flash, the prompt emission, was followed by a long-lasting afterglow created as a jet of material, traveling at nearly the speed of light, slammed into the thin gas between stars. This collision was thought to create a shockwave that accelerated particles, making them glow. But the models predicted this glow would fade quickly at the highest energies. The fact that MAGIC saw such brilliant TeV light, and that it persisted for much longer than anyone expected, means our understanding of that shockwave is fundamentally wrong. The physics of these relativistic collisions is far more complex and efficient at pumping particles to insane energies than we ever dreamed. It forces us to consider new mechanisms, perhaps involving the magnetic fields within the jet itself, which are acting like colossal natural particle accelerators, far more powerful than anything we could ever build on Earth. These first TeV photons are not just a new data point. They are a floodlight, illuminating the hidden mechanics of the universe's most extreme accelerators and rewriting the chapter on how matter behaves at the very edge of physics. Even the most familiar stars can hide surprising secrets. After decades of surveying the sky, astronomers have just identified a bizarre new type of variable star, a class of elderly suns they call the old smokers. These are not brilliant, youthful stars, but ancient, retiring red giants located in the crowded central bulge of our Milky Way. For most of their long lives, they sit quietly, barely changing in brightness. Then, without any clear warning, they undergo a dramatic transformation. They dim dramatically, fading by as much as 97%, becoming almost invisible for months or even years at a time. The cause of this great dimming is not an internal pulse or a distant planet passing in front. These old stars are literally puffing out vast clouds of dust, like cosmic smokers exhaling rings of smoke. The clouds condense from material ejected by the star itself, forming a shroud that temporarily blocks its light from our view. Eventually, the cloud dissipates or drifts away, and the star returns to its normal brightness, only to repeat the cycle again years or decades later. This strange behavior represents an entirely new, previously hidden stage of stellar evolution. For our own Sun, this is a glimpse of a distant future, a phase it will one day enter billions of years from now. The discovery forces us to rewrite the final chapters of a star's life story. We thought we understood the death of sun-like stars, a process leading to a planetary nebula. But these old smokers reveal a much more erratic and complex final act, a period of fits and starts where the star sheds its outer layers not in a steady wind, but in great, episodic belches of cosmic soot. This has a profound consequence for the entire galaxy. These repeated puffs are a primary delivery mechanism for heavy elements. Each cloud of dust is rich with complex molecules and elements forged in the star's core, including the carbon, silicon, and iron that are the building blocks of planets and life itself. The old smokers are therefore galactic recyclers, sitting in the dense central regions and systematically seeding the interstellar medium with the raw materials for future generations of stars, planets, and perhaps even living things. They are the quiet, elderly giants in the galaxy's core, occasionally clearing their dusty throats to sprinkle the ingredients of creation back into the cosmic void. The ancient light of the early universe holds a stunning secret, a pair of cosmic beacons blazing from an era just after the dawn of time. The James Webb Space Telescope has confirmed the existence of a binary quasar, two intensely bright objects, each one the active, feeding supermassive black hole at the heart of a young galaxy. What makes this discovery so revolutionary is not just that they are a pair, but their incredible age. We are seeing them as they were when the universe was only about 3/4 of a billion years old, a mere fraction of its current age. This is a snapshot from the cosmic nursery, a picture of two infant galaxies caught in the act of a titanic collision. Their central black holes, already monstrously large, are feasting on the vast amounts of gas funneled in by the galactic merger, lighting up as quasars, the most luminous objects in existence. For a long time, a central question in astronomy has been how supermassive black holes, which can grow to billions of times the mass of our Sun, manage to get so big so quickly in the young cosmos. This double quasar is a crucial piece of the puzzle. It provides direct evidence for a long-theorized growth mechanism, galactic mergers. The theory suggests that the first seed black holes, formed from the collapse of the earliest stars, did not grow in isolation. Instead, their host galaxies constantly collided and merged throughout cosmic history. Each merger would funnel fresh gas and stars toward the center, feeding the black holes and causing them to shine brilliantly as quasars, while also smashing the black holes together to form an even more massive single entity. This binary system is a frozen moment in that process, a fleeting stage before the two black holes themselves eventually spiral together and merge in a cataclysmic event that will ripple the fabric of space-time. This single observation powerfully confirms that the growth of the largest structures in the universe is a violent, collaborative process, driven by a relentless cosmic dance of collision and consumption. That rhythmic cosmic heartbeat is not the only message carried across the void. Another signal, a single, fleeting shout, has traveled for more than 8 billion years to reach our telescopes. This is the most distant fast radio burst ever detected, a burst of energy so immense it defies belief. In the space of a single millisecond, this event released more energy than our Sun will emit over the course of 30 long years. It is a cosmic flashbulb, momentarily outshining entire galaxies. But its true value is not just in its raw power, it is in the journey it took. For 8 billion years, this pulse of radio waves has been racing through the vast, empty spaces between galaxies. And it is in that emptiness that the burst encountered the ghostly presence of the cosmic web. As the radio waves traversed these immense voids, they interacted with the sparse, invisible sea of ionized particles that is thought to make up the missing normal matter in the universe. This interaction is incredibly subtle, but it leaves a fingerprint, a slight smearing of the signal's different frequencies. By measuring this smear, astronomers can effectively weigh the diffuse material the burst passed through. Think of it like listening to a sound as it travels through fog. The way the moisture subtly changes the quality of the noise, telling you something about the density of the air. This single, ancient burst has become a precision scale, allowing us for the first time to measure the total amount of this normal yet invisible matter strung along the filaments of the cosmic web. The measurement confirmed a stunning fact, that the models were right. All the atoms that should be there, according to our theories of the Big Bang, are indeed there. They are just floating in a form too thin and hot for our telescopes to see directly. This 1 millisecond of cosmic noise, a shout from when the universe was less than half its current age, has finally allowed us to put our finger on the scales of creation and account for the missing stuff of the cosmos. The discovery of a planet where none should exist is rewriting the rules of planetary birth. Astronomers have found a world called TOI 5205b, a gas giant larger than Jupiter, locked in a tight orbit around a tiny red dwarf star. This star is a cosmic commoner, a small, cool, and faint type known as an M-dwarf, which makes up the vast majority of stars in our galaxy. The sheer mismatch in size is staggering. The planet is so large that its star is only about 4 times bigger than it is. This is the cosmic equivalent of a pea orbiting a grape. According to our established theories of planet formation, this system should be impossible. The core accretion model tells us that planets form from the leftover dust and gas swirling around a young star. For a gas giant to grow to the size of Jupiter, it needs a massive amount of solid material to first build a rocky core 10 times the mass of Earth, and then a huge reservoir of gas to envelop it. A small, faint red dwarf simply does not have a protoplanetary disk with enough raw material to accomplish this. It is like trying to build a mansion with only a handful of bricks and a thimbleful of mortar. The existence of this forbidden planet forces a dramatic rethink. Perhaps this giant world did not form where we see it today, but instead migrated inward from the outer reaches of the system after its birth. Or maybe the disk of material around this small star was far denser and more massive than we believed possible, packing enough punch to forge a giant. This single, unlikely world challenges our most fundamental assumptions and suggests that planets, even gas giants, might be far more common around the galaxy's most numerous stars than we ever dreamed. Out in the frozen darkness, a tiny world is breaking one of astronomy's oldest rules. The dwarf planet Quaoar, a distant resident of the Kuiper belt, has been found to possess a dense, narrow ring system, a discovery that would be exciting enough on its own. But the real shock is the ring's location. It orbits far outside Quaoar's Roche limit. This limit is a fundamental line in the sand, a distance calculated by physicists where the gravitational tides from a parent body become so strong that they prevent any loose material from clumping together. Inside the Roche limit, rings can exist, the shattered remains of moons that wandered too close. Outside of it, the particles should feel less of a disruptive pull, and their mutual gravity should cause them to coalesce, snowballing over time into a solid moon. Quaoar's ring sits calmly in this forbidden zone, a place where it has no right to exist. It defies the basic physics we have used for over a century to explain everything from Saturn's glorious bands to the formation of our own moon. So what invisible force is holding this ring together, preventing its inevitable collapse into a new world? The leading suspect is Quaoar's own moon, Waywatt. This small companion, orbiting even farther out, may be acting as a cosmic shepherd. Through its gravitational influence, Waywatt could be creating resonances, rhythmic pushes and pulls that keep the ring particles jostling just enough to prevent them from peacefully accreting. Another theory suggests that the individual particles in the ring might be exceptionally fluffy and bouncy, like fractal snowflakes, so that when they gently collide, they drift apart instead of sticking together. This single, tenuous ring around a small, frozen world is a monumental puzzle. It forces us to reconsider the delicate balance of forces in every disk of material, from the infant solar systems around young stars to the vast whirlpools of galaxies. The rules of moon formation, it seems, are not as absolute as we once believed. Our galaxy is threaded with invisible force fields, and we are just beginning to see their shape. For the first time, astronomers have woven together data from the Gaia spacecraft and other observatories to produce a detailed map of the Milky Way's magnetic field, revealing its structure in the faint dust and gas between the stars. These are not simple, uniform lines. The field manifests as countless delicate filaments, like cosmic hairs, each one a strand of magnetic force twisting through the void. To grasp this, picture the way iron filings align around a simple bar magnet, tracing out the invisible lines of force. Now, magnify that image to a galactic scale, with these magnetic hairs woven through every nebula and every dark cloud. Mapping them required a clever trick. Gaia provided the precise positions and distances to over 1 billion stars, while other telescopes measured a specific property of starlight called polarization. As light travels through clouds of dust that are aligned with these magnetic fields, its waves become preferentially oriented or polarized. By combining the location of the dust with the polarization of the light passing through it, scientists could trace the direction and strength of the magnetic hairs themselves. This is more than a beautiful map. These magnetic filaments are fundamental architects of star formation. Within a vast, turbulent cloud of gas, these fields provide a skeletal structure, a kind of cosmic scaffolding. Gravity wants to pull the gas inward to collapse and form stars, but the magnetic pressure pushes back, providing support that can slow or even prevent the collapse. They channel the flow of gas, guiding it along their lines and helping to determine the final mass and number of stars that will be born. In a very real sense, these invisible hairs are the ghostly midwives of stellar birth. Their influence extends far beyond the cradle. Our galaxy is constantly bombarded by cosmic rays, high-energy particles racing across the universe at nearly the speed of light. When these charged particles encounter the galaxy's magnetic field, they do not travel in straight lines. They spiral around the magnetic hairs, zigzagging and bouncing their way across the galaxy. This magnetic maze acts as both a shield and a trap, deflecting some rays and confining others, shaping the paths of these energetic messengers as they journey to our solar system. Understanding this intricate magnetic tapestry is therefore essential to understanding both the birth of stars and the constant, invisible rain of particles from deep space, revealing a galaxy shaped by forces we are only now learning to see. Some worlds are so light they seem to defy the very laws of physics. WSP 107b is one of these so-called super-puff planets, a gas giant nearly the size of Jupiter, but with less than 1/10 of its mass. Its density is so incredibly low it has been compared to cotton candy, a world you could theoretically wade through if it had a surface. For years, astronomers assumed its extreme fluffiness was due to an internal heat source, perhaps from a wildly eccentric orbit. cooking the planet from the inside and causing its atmosphere to billow outward like a hot air balloon. But new, more precise observations have introduced a stunning alternative. The James Webb Space Telescope's latest data suggests that a significant portion of the planet's apparent size might not be the planet itself at all, but a colossal system of rings. This is not a simple, thin band like Saturn's. To account for the measurements, this ring system would have to be immense, stretching far out from the planet's main body and composed of countless particles of ice and rock. As the planet passes in front of its star, these rings block an additional sliver of starlight, making the entire object seem much larger than it truly is. This elegant solution turns our understanding of superpuffs on its head. We may not be looking at a single, impossibly inflated atmosphere, but at a more normal-sized planet wearing a gigantic, cosmic hula hoop. The implications ripple outward. If one superpuff is actually a ringed world, how many others might be hiding similar secrets? This forces us to reconsider every oddly bloated planet we have found. Are they truly cosmic cotton candy? Or are many of them simply dressed in magnificent, unseen rings, their true nature disguised by a brilliant celestial illusion? Beneath the brilliant bursts and swirling galaxies, the universe holds a deeper, more fundamental rhythm. Scientists have just confirmed the existence of a cosmic hum, a low-frequency vibration that resonates through the very fabric of space and time itself. This is the gravitational wave background, and its discovery marks the opening of an entirely new sense with which we can perceive the cosmos. For over a decade, radio telescopes have been monitoring the precise, regular flashes from a network of cosmic lighthouses known as millisecond pulsars. These spinning neutron stars are nature's most perfect clocks, their radio pulses arriving on Earth with a predictability that rivals our best atomic timepieces. But researchers noticed something strange. The ticks from these distant clocks were not perfectly consistent. They were arriving slightly early or late, in a coordinated, wave-like pattern across the sky. The only possible explanation was that the space between us and the pulsars was itself stretching and squeezing. The clocks were not wrong. The stage upon which they sat was vibrating. This hum is the collective echo of countless pairs of supermassive black holes, each one millions or even billions of times the mass of our Sun, orbiting one another in the hearts of distant, merged galaxies. Think of it as a cosmic choir, with each binary black hole pair contributing a single, low note to a chorus that has been singing for billions of years. Until now, this entire dimension of the universe was completely silent to us. We could see the light from these galactic collisions, but we were deaf to their deepest gravitational rhythm. This discovery confirms a long-held prediction of Einstein's theory, and gives us a direct way to listen to the universe's most massive objects as they dance through the eons. This hum is more than just a new sound, it is a history book. By studying its properties, we can begin to take a census of these monstrous binary systems. We can learn how often galaxies merge, how their central black holes find each other, and how they eventually spiral together in the most energetic events since the Big Bang. The gravitational wave background is the steady, background music to the cosmic story of structure and growth. A fundamental vibration that has been there all along, waiting for us to learn how to listen. These icy eruptions are rewriting the story of a comet's death. In the dark reaches beyond Jupiter, a comet known as 12P/Pons Brooks has begun to stir on its long journey toward the Sun. Astronomers watched in awe as it underwent a series of dramatic outbursts, violently expelling massive amounts of gas and dust from its frozen nucleus. But one particular eruption was so immense and asymmetrical that it created a truly bizarre sight, a dark shadow across the comet's bright coma that made it appear to have grown a pair of devil-like horns. This was no malevolent sign. It was a cosmic illusion created by cryovolcanism. Unlike the molten rock of terrestrial volcanoes, This comet was spewing cryomagma, a frigid slurry of water ice, ammonia, dust, and complex organic compounds that exploded into space when subsurface ices were heated by the distant sun. The horns were simply the shadowed regions of an irregularly shaped nucleus, peeking through a vast, lopsided plume of its own erupting material. These outbursts reveal that comets are not just simple, inert, dirty snowballs passively melting as they approach our star. They are geologically active worlds, with pockets of volatile ices trapped under pressure beneath a dark, insulating crust. As sunlight penetrates this crust, it turns these subsurface ices directly from solid to gas in a process called sublimation. The pressure builds until the weakest points on the surface fracture, leading to a violent, jet-like eruption that can blast millions of tons of material into the vacuum. The temporary horns of 12P/Pons Brooks were a direct window into this explosive process, showing us that a comet's approach to the inner solar system is a traumatic, fitful transition, not a gentle thaw. Each cryovolcanic blast seeds the solar system with water and the complex carbon-based molecules that are the fundamental ingredients for life, raising a profound question about our own origins. Did a comet like this, in the deep past, deliver the very water that fills our oceans and the organic compounds that sparked life on Earth? This final discovery brings our cosmic survey full circle, from the largest structures to the light of a single, distant world. The James Webb Space Telescope has achieved what was once considered impossible, capturing the first direct light from a rocky exoplanet outside our solar system. The target was TRAPPIST-1c, a planet in the famed system of 7 Earth-sized worlds orbiting a cool red dwarf star. For years, our only way to study such planets was the transit method, watching for the tiny dip in starlight as a world passed in front of its sun. This time, Webb did something radically different. It used its mid-infrared instrument to stare at the TRAPPIST-1 system and separate the infinitesimally faint heat signature of the planet itself from the overwhelming glare of its host star. This is the astronomical equivalent of discerning the warmth of a single candle flame held next to a blazing searchlight from millions of miles away. The technical triumph is staggering, but the scientific result is what truly redefines our search for life. The initial data from this direct detection revealed a startlingly small amount of heat. The planet's dayside temperature is much higher than it should be if it possessed a substantial, Earth-like atmosphere. A thick atmosphere would naturally redistribute heat from the scorching dayside to the frigid nightside, smoothing out the temperature extremes. The fact that Webb did not see this effect strongly suggests that TRAPPIST-1c is a bare, scorched rock, either possessing a very thin atmosphere or none at all. This world, once a prime candidate in the habitable zone, now appears to be a barren orb, its potential for life likely stripped away by the intense radiation and flares from its volatile red dwarf star. This finding is not a disappointment, but a critical waypoint. It tells us that even planets in the so-called Goldilocks zone are not guaranteed a protective blanket of air. It refines our search, guiding us to look more closely at its sibling worlds in the same system, like TRAPPIST-1e, which orbits farther out and might have better retained its atmosphere. This first direct gleam of light from another rock is a monumental step, proving we can now move beyond shadows and begin to truly feel the temperature of alien worlds, bringing us one step closer to finding one that feels like home. From rogue black holes to forbidden planets, these 25 discoveries paint a picture of a cosmos far more diverse and strange than we ever imagined. Each one serves as a stark reminder that the universe is not bound by our current understanding. It constantly challenges the rules we write, forcing us to redraw the maps of reality. These are not just new entries in a catalog. They are fundamental shifts, pushing the boundaries of science and redefining our place in the grand scheme of things. We are not the center of the universe, but we are the part of it that has begun to wake up, to look out into the darkness and ask questions, The journey of discovery has only just begun. So the next time you find yourself under a clear night sky, take a moment to look up. Remember the dark galaxies, the humming gravitational waves, and the distant watery worlds. Wonder at the incredible fact that we are here to witness it all. We want to hear which of these cosmic marvels captured your imagination the most. Was it the star with impossible chemistry, the phantom galaxy of dark matter, or the potential biosignature on a distant water world? Share your thoughts in the comments below, and let's keep looking up together.